For any triangle ABC, show that the sum of cotangent of A over 2, cotangent of B over 2 and cotangent of C over 2 equals S squared over delta. Okay, let us begin. Now, before proceeding, let's try to understand the terms that are being used here. So here we will first consider a triangle ABC. If we consider the side opposite to angle A, angle B and angle C, those sides which are BC, C and AB respectively are going to be represented by the letters A, B and C in lowercase. Now, when we take the sum of the three sides, that's going to give us the perimeter of the triangle. If we take half of that perimeter, that gives us the semi-perimeter of the triangle, which is going to be denoted by the letter S in lowercase. So that's what the S on the right hand side means. That's the semi-perimeter of the triangle ABC. Next we have delta here. So delta is going to represent the area of the triangle. Now the area of the triangle, we have a standard formula for this. It's given by the Heron's formula, where we have the square root of S multiplied to S minus A times S minus B times S minus C. Next, on the left hand side, we have three half angle formulas. So let's specify these formulas. Cotangent of A over 2, that's given by the square root of S multiplied to S minus A over S minus B times S minus C. Similarly, we have the half angle formula for cotangent of B over 2 and cotangent of C over 2. So we'll start from the left hand side. We will find the sum. So here we have the square root of, so we are using the formula for cotangent of A over 2. We have square root of S over times S minus A. That will get multiplied to S minus B times S minus C. Added to the square root of S times S minus B divided by S minus A times S minus C. Added to the square root of S multiplied to S minus C divided by S minus A times S minus B. This is going to be equals to, now we'll take the common denominator. We're going to combine the three terms. The common denominator is going to be the square root of S minus A multiplied to S minus B times S minus C. Now we will start computing with the numerator part. So we have square root of S multiplied to S minus A. Added to the second term will become square root of S multiplied to S minus B. Added to the third term, which is square root of S multiplied to S minus C. Fine. Now from the three terms in the numerator, we can take square root of S as the common factor. That gets multiplied to S minus A added to S minus B plus S minus C. So that means we have 3S minus A minus B minus C whole divided by the square root of, we have S minus A times S minus B times S minus C. Now, let's do one thing. So let's multiply the numerator and the denominator with square root of S. So that's going to give us, we have S multiplied to 3S minus A plus B plus C whole divided by square root of, so we're going to combine the square root of S with the denominator. So that gives us square root of S times S minus A times S minus B times S minus C. Now, A plus B plus C over 2, that's the semi-perimeter of the triangle. So that means A plus B plus C will be equals to 2 times S. We can replace this A plus B plus C with 2S. And that's going to now give us S multiplied to 3S minus 2S. And the denominator, that's the Heron's formula. So that's the area of the triangle delta. So we now have S multiplied to 3S minus 2S. So that's S. We have S times S over delta, which is equals to S squared over delta. And that's exactly the expression on the right hand side. So we have showed that the sum of cotangent of A over 2, cotangent of B over 2 and cotangent of C over 2 equals to S squared over delta.